This is a heat exchanger thing, taking the heat. And it's an article that I wrote for Motor Age, and it was published back in April of 2010, but I'm gonna run you guys through it, because there's some of the stuff that's just fairly basic knowledge that you need to know. And so take notes on this, and I'm gonna evaluate your notes. So if you hand me a piece of paper that ain't got no notes on it, that means you weren't paying attention, and you didn't take what I was telling you seriously, and I'll give you a lousy grade on this thing. It's gonna be just like a test, okay? All right, so let's loosely define the first and second laws of thermodynamics by saying that heat must be generated by something at the expense of something else. You got that? Did you learn that in science? Heat has to be generated by something expensive. You got to burn some wood to get it. You got to burn some gas to get it, right? That's the first law of thermodynamics. Whenever heat transfer takes place, something's always lost. You're always going to lose something. You're never going to be able to recover whatever it was you burned to make the heat. Gasoline's oxidized in a process we call burning. As it burns, it expands. As it expands, it applies force, and its heat is it's immediate. Now, the conversion of gasoline power is not 100% efficient. It's not 100% efficient. Gasoline is not 100% efficient. There's a lot of energies consumed during the production of it that can't be recovered. Where does the energy go? What does it turn into? Heat. It turns into heat, and that heat has got to be dealt with, right? An efficient means of transferring and dissipating wasted heat has got to be applied, or the work producing machinery gets destroyed. Okay, so heat exchangers don't always protect machinery. Sometimes their purpose is more utilitarian, like the heater core, the evaporator, the condenser, the heat exchangers working together. And I'm going to go ahead and bring my little PowerPoint up here, because I can do that too. Let me do that, because I got to be able to show you guys some pictures while I'm doing this. And while that's coming up, we'll go ahead and fire up the projector. Who said that? All right then. Now, to prevent heat damage on liquid-cooled engines, coolants pumped through the engine block and the cylinder heads to maintain the integrity of these components through the process of convection. Now, Lundy went over this yesterday. Convection, conduction, and radiation. You know, convection is whenever you absorb the heat and you carry it away with coolant or air or something, right? Conduction is out when something's touching something else. If you touch something hot, you're going to feel hot. You ever burn your hand? You know, you can take a cool water and warm water and run it through two different tubes that are twisted around each other. So you twist these tubes around each other so it's like a rope sort of, then you run cool water and warm water through the, opposite tubes. And if you wrap your hand around that, your brain will tell you you've burned your hand, and you'll let go of it involuntarily. Even though there's no danger there, you'll feel like you've burned your hand. But just a little side there. Head gaskets have little ports to let the coolant flow through. They're really slow, right? That's part of that's what's going on there. And so if you have I was talking the other day in one of my engine repair classes about, there was a guy that was back there putting head gaskets on a Taurus with a 3.8 in it, and he got those head gaskets out, and he realized the ones he pulled off were the coolant passages where it had little bitty holes about 1/4 of an inch in diameter, and the one that he was getting ready to put on there had holes the exact same size as what was in the cylinder head. Okay, so he was saying, this is not right. And when I told the parts guy about it, he called Felpro, they went, oh no, because if the coolant's flowing through there too fast, it doesn't have time to collect the heat from the head, because the head's the hottest part of the engine, and it's going to actually burn something up. Now, heat travels to colder matter by default. Heat is what travels, cold is not. You know when you got cold air coming in from outside, you know how you get really upset about that because you don't like for it to, well actually you got, heat is what's moving. All right, give Joe one of them neat note sheets. You got them over there. All right. Okay, so the radiator's mounted so that it's supposed to receive a high volume of air at road speed, and the air is cooler than the radio, so heat's picked up by the engine and keeps on moving. And I'm going to do something to reboot this machine, I guess. Okay. All right, let me see if I can reboot it. All right, so heat transfer in a radiator. What does a radiator look like? How would you describe a radiator to somebody that had never seen one?
It's a big tube, just back and forth to the tube, and a bunch of fins so it carries the heat away.
Yeah, so you got that. The heat actually is, the coolant's flowing through the tubes, and the fins actually grab, pull the heat out of the tubes, because the heat's going to go to where the tubes are, and then the air blowing through there actually carries the heat away. And so whenever the coolant or whatever, if you got an oil cooler, if you got a transmission cooler, now where's the transmission cooler at on most cars?
Right on the radiator?
It's in the radiator. Oh, well, some of them got it outside the radiator in front of it. Some of them actually have got it inside the radiator.
I thought the one on the outside, most people have to put out there.
Yeah, well, some of them have that out there by default. They do, and all that. So anyway, basically there's thousands of contact points in a radiator where these little tubes, where the coolant's flowing through the little tubes are meeting that. Now, what is an intercooler? Who can tell me what an intercooler is? Some of you hot rodding that, so I don't know what an intercooler is. Huh? An intercooler.
I've heard the term, but I don't know.
I know the term, I can't describe it to you.
Okay, whenever you've got a supercharger or a turbocharger, you're actually squeezing the air, right? When you squeeze air, you make it hot, just like a diesel does whenever it's squeezing that air, and then you can shoot fuel in there and it's 1,000 degrees, because you get 2 pounds, 2 degrees Fahrenheit for every pound of compression. Well, you want, what's the problem with hot air going into your engine? If you got hot air going into your engine and trying to get power, you want rich, cool air with a lot of oxygen molecules per cubic inch of air. So you're going to run it through a radiator that's there to cool the air. Outside air is going to cool the air that's been compressed by the turbocharger or supercharger, and that's actually going to make that air a whole lot cooler and a whole lot richer. Come on. And so here we go. We got a heat exchanger that we call an intercooler that's for that purpose. Some of them don't use air, they use coolant to do that.
The intercooler is the thing that when a car with a turbo stops, it shoots out the air streams, right?
Oh, that's the.
No, actually, your turbocharger is producing pressurized air, and you're going to run it through something on the way to the engine that looks like a radiator. And you got the air flowing through that little thing, just like a radiator, and then you got air flowing through here to take the heat out that you've generated with your compressor. You got it?
I got that, but I was asking what is it on a turbo car that launches like steam? Like when the car will stop, it'll go.
Yeah. I'm not exactly sure what you're talking about there. I may be a dummy, but I'm kind of confused about that.
Cars running naturally, so when they pull up, it shoots out.
Yeah.
Lead valve.
Yeah.
Yeah, that's something that they do on purpose. It's not anything that has to be done. It's just you can make all. They actually got some stuff you can put in your tailpipe to make stuff happen back there, like flame and all that. Well, we don't often the engine that originally was designed. How do lawnmower engines get cooled in motorcycles?
Air
Cool.
Because in what principles are at work there?
Open.
They've got aluminum fins on the block.
So that's conduction, convection, or radiation. What is it?
I'm gonna say it's convection.
Huh?
Conduction.
Cooling by air, I mean,
Yeah.
it's all, I'm gonna say, convection.
Convection.
Yeah, convection.
Mm-hmm.
All right. So basically, it's conveying the air is actually making contact. So it's conduction and convection. That's basically what that is. All right. Half the width of each fan blade. If you're looking down in there, like on our Bronco, where you got a belt-driven fan, if you're looking down through there, and I'm gonna tell you this is really important, and I didn't know this for years, but you've got your fan shroud right here, right? Like you're looking down. This is looking down on top of the engine. If you've got a fan in there, that fan should be only halfway. If anybody ever mounts a fan on one, and that fan, and this is your fan, your fan blades coming out here like this. You're looking at the end of your fan blades. If that fan blades is halfway out, then you're like you're supposed to be. If it's buried in that shroud, like if the shroud is in here like this, that engine will overheat. And I found that out the hard way when somebody wanted a thicker radiator put on their vehicle so it would heat better. We got one from an Explorer, put it on a Ranger, and that son of a gun, we could not get it to run cool until the shop foreman came and he says, that fan's supposed to be split in the middle. You're supposed to see half the fan when you look down through there. Somebody wake Lundy up. you're supposed to put half the fan down, sticking out there, right? Okay, when you stick half the fan out there, it's gonna run cool. And so I said, I didn't know about, but I'm gonna try this. So I took the radiator shroud off and I cut about an inch off of it so you'd see half the fan blades, and that thing ran cool as a cucumber. That just blew me away. I couldn't believe it. All right, so anyway, here we go. So here we've got, how did the old Model Ts get cooled? If they didn't have a water pump, the old Ford cars, the old, Model Ts, to begin with, you know where the gas tank was on those old Model T Fords?
On the hood?
In front of the windshield.
Yeah. It was-
Gravity feed into the carburetor. If you're going up a hill, it would quit running. You'd turn out back up the hill because of gravity feed. They had those things fixed so that they had a place on the head like this. And you'll see this if you look at those. And this hose comes out and goes to the radiator, sort of more. And what happens is, it was like a coffee pot. It would percolate that water up through there, then it would drain through the radiator and it would come back in there. So it basically percolated through the radiator. You got it? All right. So anyway, I'm just giving you this because a lot of the times this is, stuff that you might think, well, this is something I don't really need to know. Well, I worked on that one doggone truck for, a lot of them, you're trying to figure out why they're overheating. If you don't understand heat transfer, you can have a problem with that. Okay, coolant pumps fail with enough frequency to where most everybody in here, have you ever replaced a water pump? Who has replaced a water pump in here?
Who has?
Who has? You all replaced a water pump. What was wrong with a water pump, the last water pump you replaced? What was wrong with it? Why'd you replace it? Huh? Well, leaking. Oh, what else can go wrong with them?
Seal, the rubber seal.
The rubber seal leaking, bearings can go bad,
Rust.
all kinds of stuff goes wrong with water pump and all that. And they got a little weep hole so it'll leak out. There's thermostats to regulate the temperature, prevent the cooling system from working too well. Cold running engines aren't fuel efficient. We talked about that yesterday. So air-cooled engines are designed with broad fins. We were talking about that a minute ago. And they typically travel at high speeds, and motorcycles do. So they can, a lot of motorcycles now have got water cooled. They got a radiator on them.
Cooled.
Huh?
Mine's liquid cooled.
Yeah, so you're gonna have a liquid-cooled motorcycle sometimes too. Old Volkswagen Beetle engines are air-cooled with fins and a powerful fan mounted in the housing above the engine is driven by the jet. But did you know they're not, the fins on those cylinders, on those jugs and on those cylinder heads aren't the only thing that cools the Volkswagen Bug engine. It's got an oil cooler in that shroud. And without that oil cooler, they'll burn that sucker up. You know what I mean? That oil cooler gets stopped up enough to where air can't go through it. You're gonna have one of those air-cooled Bug engines will overheat. So basically, if somebody says, somebody asks you about a radiator for a Volkswagen Beetle, I mean the old one, they're making a joke. You say, well, you mean that little oil cooler up in the shroud? And they go, huh? Because most people think, well, a Volkswagen don't have a radiator because they don't have coolant. But it uses oil to cool the engine. See, it cools the oil and the oil cools the engine. That's pretty sharp the way they did that.
The oil cooled the engine more than the radiator fluid does?
It does a heck of a good job, but not more because it's not going to cool the head. The head gets really hot. The head's the hottest part of the engine. See what
I read somewhere where the oil takes away like 60% of the heat.
Oil takes away a lot of heat, but there's no way the oil can cool the head. I mean, you're not going to have the head cooled by oil. So anyway, the only heat producing part of an engine that needs to be managed is not, I mean, there's more to it than fuel. On supercharged engines, the air jammers squeeze in the atmosphere. That's what I was talking about, the intercooler and all that sort of stuff. Fluids that are moved under pressure by a positive displacement pump, like the power steering pump's got to be cooled too. So how do we do that? Did you know that power steering fluid's got to be cooled?
Yes.
All right, so how do you cool it? What's the only way, I mean, what are the ways you've seen it cool? Got any way? I mean, tell me how they usually cool power steering fluid. Anybody know?
I want to say that on the Humvees, there's a power steering cooler line.
Yeah,
that
there
goes
is.
From the radiator.
And yeah, that's probably right. And you also are going to see other things. Let me see if I can get it here. See if I can get that to open up. I didn't need that to jump up in my face. All right, so, all right, let me see right here. If I can get that PowerPoint thing to open, I'll show you guys a picture or two while we're here, because we ain't going to have a much more time in here. Okay, what about if you're going to make a power steering cooler, how would you do it?
I do it just like a radiator.
That works pretty good too, but is it necessary to have cooling that good? Or do you know?
Because it sure
Huh?
helps.
Yes.
Not really. Now that's what I was talking about a while ago, that one there. This right here is the EGR cooler. on a Power Stroke. And that right there's another EGR cooler. It's the newer style. And that other part you see down on the left, that's an engine oil cooler. That engine oil cooler on that Power Stroke is really important. That's an EGR cooler on a 6.4 liter. The front one, they got a horizontal and a vertical one. That's a vertical one. What is that right there we're looking at in that picture?
Air conditioning,
Part of it. What else? What's that other piece?
heater core,
So look at that. You got two of those doggone heat exchangers right there in the dash on that F-150.
and a blend door.
And a blend door to let that air go through the heater core if you want warm air. Because even if you've air conditioned air, you can heat it back up with a heater core. What does the air conditioner heat exchanger do that the heater core cannot do? How many of you guys ever driving an old car or a car air conditioner didn't work on?
Coolant.
Well, yeah, but you turn it on defrost. Have you ever had the windshield fog up when you turn the defroster on?
Yeah.
Because of humidity? That stinks. But if you turn on your, nowadays, when you turn it on defrost, if you got air conditioner that works, it's going to kick the compressor on. That evaporator is going to get that air dried out because it's going to go past it. It's going to sweat like a glass of tea. And then it's going to go through that heater core, and you're going to have dry, warm air going up on your windshield. It clears it up real fast. That's because of the AC. All right, what's that line right there? Why is it so long?
That's the power steering fluid.
Power steering fluid passes through that line, and that's what cools the power steering. You understand? All right. Now you got,
Like a trombone.
huh?
You talking about that trombone in there?
That long U-shaped line,
Yeah.
that power steering fluid goes all the way through that line. It's mounted in front of that cross member, so it gets a lot of air. It ain't got no cooling fins, but it don't need them. Just the surface of that pipe. And the engineers, what they do is they have airflow through there. They run that power steer and they make it, generate heat. And they measure the temperature of the fluid going in and coming out. And they can tell if this is sufficient. This is cheaper than building something with fins on it. See what I'm saying? You just run the line a long way. All right, now look at this. You never think about that. What are we looking at there?
With a steel pipe,
That is the EGR. Whenever you got EGR, getting EGR through a pipe that's long like that, that EGR is cooled a little bit because it's going so far through that metal pipe. Now in the ages ago, when the EGR used to come from the crossover passage in the intake manifold, it didn't have a chance to cool off very much. You got me? All right, and so that's what the deal was on that. But now they run it just a long way. Okay, now something else you got. See this EGR cooler here? Now I want you to look over there. You see the green part? That's where coolant is. That's what this looks like in the real world. That's what it looks like on a cutaway engine I took a picture of. That's the oil cooler right there. Okay, so here's where your exhaust, your EGR is going. EGR needs to be cooled too because it's inert gas. And if you're trying to keep your combustion chamber cool, you really don't need hot inert gas going in there, do you? So you're going to cool your EGR. And if you remember, you cool the EGR on a gas burner like that on a diesel, it's more important. So you, and you know, what happens when you open the EGR valve on a gas burner? How does it change the sound of the engine? What does it sound like when it's running? It runs rough, don't it? I mean, it starts idling really rough. You know what happens when you open the EGR on a diesel? It gets quiet. It doesn't get rough, it just gets quiet. And this rattling that you hear, it quietens it down. It's a different deal. But anyway, that oil cooler is really important too. It's right at the top of that valley on those 6 liters. All right. Now this right here is a cool little deal I'm going to show you. This little thing in the top that you're seeing in this picture up here, that device up there, is that's a turbocharger. It controls the turbocharger on the 6.4. Okay. It's actually the turbocharger control. And on the bottom down there, you've got a fuel cooler. You never will see it. And you've also, it's got a special cooling system. This little radiator cap is a special cooling system that's dedicated just to the cooling of the fuel and to the cooling of that supercharger control. And so, turbocharger control, the variable geometry turbocharger is controlled by this thing. Now I'm going to tell you this in closing. The very thing it's got a CAN bus communication with the PCM. And if the PCM sends a message to this box on the top and it says, I need this particular turbo angle for my turbocharger. This thing is smart enough to where it talks back to the engine controller and it says, I'm not giving you anything until you turn on that pump over there and cool me off. You know what I'm saying? Is that cool or what? So, but anyway, that's just a little bit. I'm just gonna give you guys a quick brush up on that, and I wanna see your notes whenever we're done with that. And I will give you guys I'll give you guys a break now, because Lundy's gonna have to leave in a minute. I'm just gonna whip through this really quick. So, let me ask you this before I shut this thing down, because I didn't wanna, make this be really long and boring. But who in here learned something you didn't know before? What about you? You learned something? What about you? You learned something? You learned something? You learned something? Huh? Huh? A little bit. All right then.